And there's no slide anymore, but
someone new will appear again.
Okay. I want to thank you, Martin, Alexandra, and David, for the nice presentation. We have, I think, a few minutes for some questions and answers, but all questions can also be sent afterwards, either to you or the Knowledge Sharing Center. The presentation will be available on the Knowledge Sharing Center. There's a quiz also there with the nice prize, as you said it here. I think we will also upload the videos. Because it didn't work here. We need to check that next time before we start the presentation. Okay, that's an improvement.
Lesson learned.
That's an improvement point on our side. But I think if there are some people with questions, we can answer those. But it's timing wise, we're I think nice in shape. But any extra questions can be also sent by mail to Knowledge Sharing Center or to ASML at the Additive Center. I'm not sure if we can see the questions. Otherwise, I have to check to my other computer and see what's there. Let's see if we have some. Okay, but if you just start, I can focus them. Okay. There was one, what's the yield on SLM? And I'm not really sure if that's a question on just SLM. Of course, it's depending on the product. Maybe the guy who's asking the question wants to have something like a percentage if you have the base material and the yield compare that to SLM.
So we have to, those values are probably in our database, but as a rough estimation, I would say 80% in XY direction, probably 70 in the Z direction. As a small rule of thumb, not exact values here, of course, but I think that's quite reliable.
Yeah. Is that also maybe depending on some post processing? You say doing some HIP like
exactly.
High pressure. Afterwards, if you don't or do that or don't, will also improve, I think, your
So of course, heat treatment afterwards, also HIP treatment, that will definitely influence the yield strength, and also the E module. So the S printed part should be roughly around 80%, I guess.
Okay, that's a good one too, because in the beginning we saw that some people said, okay, reliability of the parts, but if you know that you have to take other material properties into account, then of course that is part of your design and you have to adapt for that one. And then there's a question from Cora. He says, is thermal post-processing available?
Yes.
Yeah,
just like other metals. Yes.
Okay. Let's see what we have then. What software was used for topology optimization?
It's a software called MSC Apex GD.
Okay, it's very specific, or are there more similar programs?
There are more similar programs. The one is a bit more extensive than the other one. Okay. We always use this one.
Then we have a question from Arnold. Arnold Amstoy, and he asks, let's see. Is powder bed fusion and VAT polymerization, do you have the chance to powder bed liquid between each part, or can it just be reused? So I'm not sure what
the material can be reused, I assume.
Also on the liquid material, I think on the powder it's maybe easier, but on the liquids it's also possible.
Well, once the material is solidified with the liquids, it cannot be reduced. So for the support structures are waste. The rest of the resin that is in the bed can be reused once refilled. For powder bed fusion processes, there are different types of machine. Most of them use a certain percentage of reused powder and then new powder. But once clean the powder, certain percentage of it can be reused for another.
And that's between 50% and 90%. So it can go really high.
Really high. Good to know, I think. Let's see what we have then. How much can SLM resist against fatigue compared to mill parts? Basically this.
That's also has to do with the post-treatment, of course, if it was hipped and heat treated, and probably after that sandblasted, or in general a smoother surface always is better for fatigue. I think I cannot say like a definitive value because it really depends on the post-treatment.
Yeah, and the core material itself is the same. But the big difference between milled part and printed parts is that with milled parts, you start with a block of material that's certified, it's completely dense. And with 3D printing, with SLM, you also reach a density of 99.9%, I think. But there's still, in the process, you basically create the material. And there's a bit of risk to it. So quality control after that is very important.
And then question on my side on this topic, I think, is there any build sample printed alongside every product, or is it only done if you have high critical products? You can say, okay, I have a critical product which is on the limit of what the material can hold and properties. Is it then always, or maybe good to print like a sample next to it to make sure that, okay, this batch on this printing process produces this strength or fatigue limit or whatever?
I guess that depends on the part.
On the criticality of the part.
Yeah, and what aspect is critical. You can also, of course, CT scan it to make sure that the quality is up to spec and to make sure that the supplier his production process is up to speed. And after you produce more, you also get the statistics to scale that down
and check on voids and stuff like that. That's why you use the CT scan.
Yeah.
Thank you. Clear. Then there's a question from Ono who says, are these examples manufactured in volume? Like you showed lots of examples, and are they also made in volume? Is it just
so for example, these are manufactured in volume, so that's hundreds. These quantities are a bit lower. What other samples do we see? In general, the parts like this, they can be manufactured in high volume, but especially in the ASML market, you want to make sure that, again, emphasizing on the quality, probably even the print bed is dedicated to your parts, and to make sure that the quality control afterwards is up to spec. So per part, you have some requirements that need to be met. But there's also, of course, the general standard of ASML that needs to be complied with by the supplier. There were also some examples where we moved the customer part from aluminium to a polymer, to PA12. Most of the cases, those examples are all produced in high quantities.
Okay, then there's another question on this combined part. You have here the integrated part. Well, how much lighter was it?
It moved from 3.5 kilograms to 1.4-ish, I think.
Okay, so that's also a decrease on power needed to move the complete machine.
Yeah.
And that's something probably most engineers don't take into account, but light, gaining mass is also in the end, over the lifetime of your machine, maybe not that big of a number, but it's there. And all with the ESG things and energy saving, that's also a good one to know.
And it's good to know that we could have decreased the weight even more, but the end customer didn't accept it because it looked too fragile. But even at the end, it would do the job perfectly.
Because that's people who need to be convinced that it can do the job, and they think it looks somewhat flimsy, and maybe we shouldn't go all the way to that. But that's something you can change in your topology program to say, okay, we go to the extreme, or we just say so many percentage over that to make sure that it's better feeling for the customer.
Yeah, exactly. And we can also simulate it on stress again, and to show that we can do it. But
for now we have a last question. It says, is there already an overview of the accuracy? Because within ASML we have lots of accurate parts and also the tiny ones. And like you stated before, AM is not a producible production method by itself. You also have to do some post machining, but I think then the accuracy will be in the post machining. Or is there also an overview of what the accuracy of the AM process itself is?
Yeah, we do have an overview of all the technologies with a general tolerance. But like you mentioned, these parts, for example, in post-processing, they need to have milling, they need to have jig to make sure that the milling is done properly. So the rule of thumb is on the sheet that we can share with the general tolerances. We'll upload to that to the site as well. But as a rule of thumb, you can take into account tolerances that you achieve with milling in general, can also be achieved with milling on stainless steel parts.
And maybe also to add there, for 3D printing, since it's a layer-wise buildup, and as I mentioned during the presentation, there are different tolerances in the XY plane and in the Z direction. So you also have to take that into account.
And yeah, you said before that if you print a first prototype and you see that there's a deformation or some deviation from the external shape, you can compensate that in the program printing.
Okay. That's why we also created the ASML inbox, just to make it very low hurdle to check in with us. We can run the simulation to see where it deforms and to adjust the design before printing. That avoids.
Okay.
Thanks.
Okay. Yeah, that's all the questions for now. So, like we said before, if there are any other questions, feel free to post them on the website before. And again, I want to thank all three of you for having this great presentation. To me, it was very good. I hope the rest also enjoyed it. And yeah, I want to thank everybody for joining us in this presentation. Thank you.
Thank you for organizing, and thanks everyone for joining the meeting.
Thanks.
It's like a TV program.